Okay, Assalamualaikum warahmatullahi wabarakatuh. So today I'm Muhammad Abdul Muiz and my teammates is Abuza and Hafizuddin bin Jasni. So the topic that we will discuss today is chapter 8, that is correlation and regression. So the first one, we have correlation coefficient. So in this subtopic, we have scatter diagram. So the point that we have to look in scatter diagram is we have to look at this point. So if this point is closely together and it go rightward and upward, so it will be strong positive. But if the point is scattered and it still go upward and rightward, it will be weak and still positive. But if the point didn't go to any direction and scatter, it will be no correlation. And if it go downward and leftward, it will be strong negative. So the second subtopic is covariance. So covariance is a measure of how much two random variables vary together. So the formula is covariance x y is equal to the sum of random x minus by mean x multiplied by random y minus by mean y and divided by n minus 1. N is the number of items in the data set. So we have one example here. So the example is calculate covariance for the following data set. So the value of x that is given is 2.1, 2.5, 3.6 and 4.0. So the mean for x is 3.1 and for y the value is 8, 10, 12 and 14. So the mean for y is 11. So using this formula, so we just put all the data and divide it by the number of data minus 1. So the result is 2.267. So it is positive, meaning that the variable are positively related. So it will be go upward and rightward.
So we will continue with the coefficient of linear correlation. So basically in statistics, the correlation coefficient R measures the strength and direction of a linear relationship between two variables on a scatter plot. The value of R is always between +1 and -1. So the formula is, this is the expanded formula. So if you want to understand more, it's basically the variation of R equal to covariant xy divided by sx over sy. So and this side of the formula is equal to covariant x and y. That's what we learned before this, and below this is actually equal to sx times with sy. So using the chart below to learn how the value of R corresponds to the strength of a relationship. So if you got the value of R between -1 until -0.5 or 1 until 0.5, meaning the strength of the R is strong. But if you got -0.5 until -0.1, 0.1 or 0.1 until 0.5, the strength is weak. And if you get either of that, instead you get -0.1 to 0.1, the strength is none or very weak. So for example, a correlation coefficient of -0.59 would be considered a strong negative relationship, whereas an R value of 0.15 would be considered a weak positive.
Next subtopic is simple linear regression. This is a statistical method that allows us to study relationships between two continuous variables. One variable is denoted as x and the other variable is denoted as y. This is a simple linear regression model. It consists of three components. First, dependent variable. Next, linear component, and the last one is random error component. The simple linear regression model can also be written as y cap I equals to beta naught plus beta 1 xi. Y cap is predicted or expected value of the outcome. X is the predictor. Beta naught is estimated y-intercept. Beta 1 is the estimated slope. And E is the experimental error estimated by E equals to y minus y cap. The image in the slide is the formulas for the estimated slope and the estimated y-intercept. Variance of experimental error. The last subtopic for chapter 8 is variance of experimental error. Sum of square error can be denoted as sum of y I minus y cap to the power of 2. So the image shows the sum squared total error formulas and the variance of experimental error formula. That's all from us. Thank you.